Hello, in this video we'll be learning about inequalities in two variables. Just last week we learned about graphing um, equations in two variables, and so today it's going to be exactly the same as that, and then we're going to add a couple pieces on top of that. So when we have an inequality with two variables, notice it is in slope-intercept form. It has the y by itself, slope times x plus the y-intercept. So what we're going to do is we're going to graph it. Let me pull a graph out of here. Alright. And I better copy this while I have a chance. Alright, so we're going to graph this on the coordinate grid, starting with the y-intercept. So we know that the y-intercept, oops, let me use green there, is going to be -2. So we're going to start with a dot on -2. And then we know the slope is 3, which we want as a fraction because we need a rise and a run. So the rise, remember slope is rise over run. So the up 3 and right 1. 1, 2, 3, 1. 2, 3, 1. And I could just keep going and making points so that it's easy for me to get that line there. Now remember, up 3, right 1, which is 3, is the same as down 3, left 1, right? Because that is also equal to +3. So I can go down 3, left 1, down 3, left 1. And I connect those and make a line. Now here's where it gets different. There's two things we need to deal with because since it's an inequality, we know that more things can be true. For instance, if I chose the point 0, 0, which is right here, let's see if it's true. 0 is less than 0 minus 2. Is this true? Yes, that's true. And because of that, we know that this is part of the answer. And if you checked any of these points on this side of the line, you would find out that all of these are correct and make this statement true. And so whoever invented graphing inequalities decided, well, we can show that by just shading on this side of the line. Now everybody knows that everything over here is correct and everything over here is not correct. Then someone said, well, what about the points on this line? Or do they work? So let's try one, 0, -2. So if I plug in 0, -2 here, I'll do it in blue. -2 would be the y value. And we're going to check if that's less than 0 minus 2. Well, those are equal, but there's not less than. So we realize that the line that we just made is actually not part of the answer, but it is a boundary. And so to show that it's not the answer, but it is a boundary, we make it a dotted line. So I'll do that by just erasing. And you can do that with your pencil as well. So you can make the straight line and then erase. Let's do some more examples. Here we go again. We have our inequality and our graph. So we're going to start with the y-intercept, which is 4. So I'm going to put a 4 here, or a dot at the 4. And then our slope is -2 this time. Again, I want to make it a fraction. I can also make it this fraction, and we'll see why in a minute. So I can go down 2, right 1. Down 2, right 1. I can keep doing that. And I'll keep going till I get to the end of the graph, right there. And then I can also go up to left 1, and notice it is actually the same type of movement. It keeps me in that same line here. I'm going to make my line. There we go. It's a little hard straight hand or free hand, but you get the idea. And now I have to decide where to shade. Well, the rule is, notice the y value. Y is the height, right? Whoops, didn't mean to make that. So y is the height. And so if the height, this is the line. Everything that we made the line from came from these numbers, right? And so if the y value, or the height, is greater than the line, then everything above or greater than the line should be correct. And you can check that by plugging in any of these points, and you'll find that it's true. We could plug in this point, 0, 0. I choose that because it's really easy. If we do that, I'll do it in green. So 0 is greater than or equal to 4. We see that that's not true. Notice it's on the wrong side of the line. So if you check a point on one side of the line and it's not true, then the other side is all correct. Now in this case, we had greater than or equal to, not just less than like it was in this one. So with greater than or equal to, that should mean that the line itself, the boundary, is true. So let's try it. Let's pick a point on the line, which was 0, 4, which although my line didn't really cross it, here we go. Okay, so 0, 4 is on the line, and we can try it out. 4 would have been the y value. 4 is greater than or equal to 0 plus 4. In this case, it is true, so the line is correct. So whoever invented graphing inequalities decided that just a straight solid line will work when it's or equal to. Let's try a new example. Y is greater than x. A lot of people struggle with this problem because a lot of the stuff is left off. It's not really left off so much as it's unnecessary. This is in slope-intercept form. This is y equals mx plus b. So you have to ask yourself, well, what's being added here? Well, nothing's being added, so we call that 0. So the b is 0, so I'm going to make a dot right at 0. And the slope, well, there's no number there. Well, technically there is a number there. There's 1x, except we just don't put it there because the fact that there's an x there means there has to be one of them. We only put a number there if there's a different amount than 1, like 2 or 3 or 5/3 or something. So the slope is 1, which we can say 1 over 1. We could also say negative 1 over negative 1. And so I'm going to slope it out like so. You get the idea. And then negative 1 goes this way. And we make our line. Don't forget the arrows. Now we know that y is greater than, so that means the height must be greater than the line. So we're going to shade above. If it was less than, then we would shade below. And then also it's greater than, not equal to, so we have to make it a dotted line. So we can do that with our eraser. And we're all set. So it's, as you can see, it's the same thing as graphing equations, except with two special rules. The rules are this, and the and not equal to. That's a possibility, although it just doesn't come up very often. That would be a dotted line, whereas this, and this would all be a solid line. And the other thing is when y is greater than, you're shading above. And when y is, move down a little bit, when y is less than, you're shading below. So those are the only differences. Thanks for watching.